Alright guys, so today we're talking about the 2010 AMC10B number 19. This is on viewer request. A circle with center O is area 156 pi, triangle ABC is equilateral, BC is a quarter circle, OA is equal to 4 root 3, point O is outside ABC. What is the side length of ABC? So we can start by drawing a graph right here. So we have a circle right here with, I'm going to just write in blue so it's more clear, with center O. And we have a triangle like this. So you might be like, well, how do you know the triangle's inside? It doesn't tell you that. Well, we know this because since the area is 156 pi, then the radius is square root 156. And OA is 4 root 3. And 4 root 3 is square root 48. Square root 48 is less than square root 156, so there's no way it could be outside. So now we have that. We have B, C, A. With this line right here connecting. And this is 4 root 3. And so what we can do right now is we can draw OB, which is the radius, and we can draw this line down as a perpendicular. So now we have this, and this is root 156. So now we get to a cool relationship. As you can see here, this is a 30, 60, 90 triangle. This is 60 degrees. So let's let the side length be x, because we're trying to find the side length. The side length, let's let it be x. Then this is x root 2, because of 30, 60, 90 properties. This is x root 3 over 2. So now we have our equation. We can do Pythagorean theorem on B, O, and then this point right here. So we can do Pythagorean theorem. What we get is x over 2 squared plus 4 root 3 plus x root 3 over 2 squared is equal to 156. And so this is x squared over 4 plus 4 root 3 is 48 plus 12s, so an sx, plus 3x squared over 4 is equal to 156. So we can simplify. We get x squared plus 12x subtracted over minus 108 is 0. And this is pretty easy factorization. We can easily tell this is just x minus 6 times x plus 18. Since x cannot be negative, this is impossible. So x is equal to 6. And since we're trying to find the side length of AC, 6b is your answer. Today we're talking about the 2010 AMC10B number 23. Entries in a 3x3 array include all digits from 1 to 9, so arrange so that every entry in every row and every column are in increasing order. How many arrays are there? Okay, so we can split this into 3 cases, and so we can start with case 1, which is center is 4. So the digits 1, 2, 8, 1 and 9 are fixed, and 2 and 8 have to be here or here. Let's just assume it's here for this problem. And we can always just multiply by 4. So if the center is 4, then we know that 3 has to be here. And if 3 is here, this has to touch 4 and 1. So if 3 is here, then there's 3 choices for here, and then and then there'll be one choice here. Because we have 5, 6, and 7 left. If we choose 7 here, then there's only one way to arrange these, because there's always one number that's bigger than the other. So this is 3 choices. So 3 times, because the 2 can be here and the 8 can be here. So that's 3 times 4, which is 12. 12 ways. Now case 2. Center is 5. So this is a little bit trickier. You first get a graph here. Again, 1, 2, 8, and 9. But in this case, the 2 and 8 placement are actually going to matter in this case. So pretty much what we have right now is this. So we just have to do casework. So let's say this is 4. So we could either put 4 there or 3 there. Sorry, 1 second. Let me just write it out. 1 second. 1, 2, 3, 5, 8, and 9. There's actually 2 more cases. Where did it go? Sorry, this is a little glitchy right now. So these are all of our cases, and we can just multiply by 2 because the 2 can be over here. So in this case, the 3 has to be here because it can't be here, because then this would not be increasing, and this would not be increasing. So the 3 is here, then there's only one way that this can be arranged. So now here. So there's 3 ways to choose this number right up here. Because any number is greater than 2 and less than 8. And then, like this case above, it will be one case down here, because there's always one way to order them. This was 3 cases. Now here, if it's 1, 2, 3, 5. So in this case, there's 3 ways for this number right here, because all of the numbers are greater than 3 and less than 8. So there's 3 ways for this number here, and again, like here, there's only one case for this. So we can add 3 here. This last case right here, 3 has to be right here. Can't be here, can't be here. And then there's 2 ways that this can happen. It's either 6 and 7 or 6 and 7. That's 2 ways. So these add up to 9 ways. Now case 3. Center is 6. You might think, oh, we have to do more casework. But no. Case 6 is actually the same as 4. Because if you think about it, it's just symmetry. 1, 2, 3, 4 is the same as 6, 7, 8, 9. So we don't actually have to count this. So center 6 will be 12. So our total is just 12 plus 12 plus 9, which is... Oh, sorry. I actually forgot. We have to multiply by 2 here, because the 2 can be in 2 different places. 9 times 2. So our final answer is actually 12 times 12 plus 18, which is 42. And is 42 one of our answers? Yep. 42. D. Hello guys, today we're talking about 2010 AMC10B number 24. High school basketball game between the Raiders and the Wildcats was tied in the first quarter. Number of points scored by the Raiders in each of the 4 quarters for an increasing geometric sequence, and the Wildcats for an increasing arithmetic sequence. And in the 4th quarter, Raiders won by 1 point. Neither team scored more than 100 points. What's the total number of teams scored by 2 teams in the first half? So we can organize this by drawing a table. So we have quarter 1, quarter 2, quarter 3, quarter 4. And here we have the Raiders, and we have the Wildcats. So quarter 1, let's say the Raiders scored X amount. And since the Wildcats, they were tied at the end of the first quarter, the Wildcats also scored X points. Here's things we're going to pick up. The Raiders form an arithmetic increasing geometric sequence. So they start XR, XR squared, XR cubed. And while the Wildcats, they still grow at a steady pace. X plus A, X plus 2A, X plus 3A. So then the Raiders scored a total of X, factoring out 1 plus R squared plus R cubed. And the Wildcats scored 4X plus 6A. So we notice that no team scored more than 100 points, so R has to be less than 4 here. Because if R is 5, this is 125. This is not going to work. So we can start testing out values, really. Because there's only 4 possible values, and R can't be 1, because then it's an increasing geometric sequence. So there's only 3 cases. Case 1, or we don't even have to call this case. It's a known 1. If R is 4. If R is 4, then 64 plus 16 plus 4 plus 1 is 85. So we have 85x is equal to 4x plus 6a plus 1, because the Raiders won by 1 point. This 81x is equal to 6a plus 1. So we can see that x has to be 1 in this case, or else it'll be over. So 81 is equal to 6a plus 1. This means that 80 is equal to 6a. And a has to be an integer. So this is impossible, because 80 is not divisible by 6. So we can eliminate the possibility of this. Let me just draw a line down. Okay, so case number 2. If R is 3. If R is 3, then we get 27 plus 9 plus 3 plus 1, which is 40. That's 40, then 40x is equal to 4x plus 6a. 1. We immediately realize this is not right, because 40 times x is always going to be an even number. 4 times x is always going to be an even number. 6 times a is always going to be an even number. But 1 is odd. So even cannot equal odd. So this is already eliminated. We don't even have to check. Now lastly, R has to be 4. Sorry, not 4. Since R is 2, we can conclude that 8 plus 4 plus 2 plus 1, which is, I believe, 15. So then we equate them, and 15x is equal to 4x plus 6a plus 1. This is 11x is equal to 8a, 6a plus 1. So 11x minus 1 is equal to 6a. So we can just start doing trial and error. Because since 15x is less than 6, x has to be less than or equal to 6. So again, there's not that many possible cases, only 6. So 66 minus 1, 65, which is obviously does not work. But 55 minus 1, 54. 54 is divisible by 6a. So there we go. So we have x is equal to 5, r is equal to 2, as you can see up here. And we know a is equal to 9. Since we're only trying to find the total number of points scored in the first half, which is this, then we could see Summing them up, we get 2x plus xr plus x plus a. So plugging this in, we get 10 plus 10 plus 14. So our answer is 34. Is 34 one of our options? Yeah, E. And that is your answer.